A naturally aspirated Colombo V12 engine revving to 9,000 RPM is a physical event. It vibrates your sternum. But in June 2024, Ferrari inaugurated a 456,000 square foot facility in Maranello that produces no exhaust notes. The new E-building is where the prancing horse will assemble its first fully electric supercar, slated for late 2025. It is the most radical pivot in the brand's 77-year history. How do you digitize a soul? I am joined by former Maranello powertrain consultant Matteo De Luca and high-performance battery architect Dr. The E-building is a shock to the system. You walk past the traditional foundry where they cast aluminum engine blocks, and suddenly you enter a clinical, white-floored laboratory dedicated to high-voltage stators and cell modules. Ferrari is not outsourcing this. They are hand-building their own high-voltage batteries, electric motors, and inverters in-house. The goal is to control the entire electric powertrain proprietary logic. They are using axial flux motors, likely sourced from their partnership with Yasa, which are incredibly thin, lightweight, and offer immense torque density. Packaging is everything. Traditional EVs use a skateboard chassis, a heavy, flat slab of batteries under the floor. That ruins the seating position and alters the yaw inertia. Ferrari cannot accept a high hit point or sluggish turn-in. Instead, they are utilizing a T-bone or mid-engine battery layout. By stacking the battery modules behind the driver, exactly where a V8 or V12 would normally sit, they preserve the polar moment of inertia. The car rotates around the driver's hips exactly like an F8 Tributo or an SF90. You maintain that razor-sharp mid-engine Berlinetta agility while carrying 400 kilograms of lithium-ion. And then there is the acoustic problem. Enzo Ferrari sold engines. The car was thrown in for free. To solve the silence, Ferrari filed a patent in 2023 for a device that amplifies the actual physical frequencies of the electric motors. They are not pumping artificial MP3 files through cabin speakers. They are using acoustic resonators connected directly to the motor housing and transmission, channeling the genuine electromagnetic whine and gear mesh into the cabin. They are tuning the stator teeth and rotor poles to generate a specific harmonic signature. It will scream, but in a completely new digital pitch. That mechanical connection extends to the throttle mapping. An EV typically gives you maximum torque at 0 RPM, a brutal neck-snapping launch that quickly fades. Ferrari's software engineers are deliberately restricting low-end torque. They map the power delivery to mimic the crescendo of a naturally aspirated engine. You have to rev the electric motors to unlock the peak output. Combine that with aggressive active aerodynamics, deployable gurney flaps, and blown diffusers to manage the extreme thermal loads of continuous track driving. And you have an EV that demands skill, rather than just acting as a point-and-shoot roller coaster. We also have to consider the chassis dynamics. With independent motors on each wheel, or at least a tri-motor setup, Ferrari achieves true torque vectoring. The software can overdrive the outside rear wheel while slightly braking the inside front, pivoting the car through a corner at Fiorano with impossible physics. The side slip angle control, the famous Ferrari software that lets you drift like a professional, will be infinitely more precise with electric motors. Adjustments happen in milliseconds, entirely independent of a mechanical limited slip differential. It will flatter the driver in ways a mechanical drivetrain simply cannot. The price for this paradigm shift will be steep. Industry intelligence prices this first electric Ferrari north of $500,000, entering low-volume production in late 2025. This isn't a mass market play, it is a technological halo car. While they are launching with advanced lithium-ion cells, the modular architecture of the E-building is explicitly designed to adapt to solid-state batteries by the end of the decade. Solid-state will eventually have the battery weight, unlocking the ultimate holy grail, an electric hypercar that weighs under 1,500 kilograms. A digital revolution in Maranello. 3 takeaways from our look at Ferrari's electric future. First, by rejecting the skateboard chassis for a mid-engine battery stack, they are preserving the iconic yaw dynamics of their classic Berlinettas. Second, the sound will be authentic, an amplified mechanical resonance of the motors, not a synthetic track. And third, the new E-building guarantees that Ferrari will build its own high-voltage components, keeping the proprietary magic in-house. Thank you to Matteo and Sarah for the incredible insights. The V12 isn't dead yet, but its electric successor is already on the test track.